Brandon Davis.
Brian Sloan, and we made an Arduino Synthesizer, so start the keyboard. So when we were designing this, we came up with some requirements that we wanted to hit for our keyboard. We wanted to be able to deal with a lot of inputs. We actually ended up interfacing a full 2 octaves, and that's way more pins than you can do on one Arduino. So we had to interface it with a second Arduino. We had to send signals from one Arduino to another, and that was one of our major design concerns. We had to make an audible output of a specific frequency, and we also had to find a way to amplify that because it was way too quiet when we were just running it from the Arduino through the DAC into the speakers. But we were able to get a bunch of different frequencies. We were actually able to enumerate most of the basic keys. So we did all of the 2 octave range for A, B, C, D, F, and G keys. And we have it so that it will change keys on the press of the button.
So we got the block diagram right here. Here's your keyboard. I'm going to go a little bit later about how exactly we made that. We were trying to think, do we want to buy one? Do we want to, find an old one and work with that? But we thought it would also be cool to make our own button array, and we're going to get a little bit more into that. Here we got the button, and that's the button that's going to change keys because, like he was saying, we don't have like white and black keys. Just everything you play is going to be in that key, which actually makes it really cool if you want to like play along with the song. Just any note you play will work if it's in the right key. And then there we got our 2 Arduinos. Coming out of the top one, going into the bottom, you see out of PV3, that's the square wave data that we have coming from the bottom 8 notes there. And then the top 7 notes are coming straight into this Arduino. And then the main software thing that we used was the SPI interface. And pretty similar to the function generator. It actually helped a lot looking at that code kind of as a reference. And then right out of there we got our DAC. Pretty similar to the function generator. We ended up using a square wave. We wanted to use a sine wave. But
we'll get into that later when we go into the integration and testing.
Yeah. And then there's our op amp right there to amplify. Going into an 8 ohm speaker. So again, here's the design overview. There's our keyboard. It has 15 buttons. Some of it goes to one Arduino, the other goes to the other half. So the one Arduino was mainly used for the SPI interfacing, and that used up a lot of the pins because it had 3 there along with the 7 buttons. And that's why we need to use the other Arduino. Again, we have our SPI with DAC and our gain stage there. So yeah, to look at how we made our keyboard, it turns out cardboard's really good for running wires because it makes it pretty clean and it's got like little lines. Yeah, perfect for it to go through. So what we decided to do was we make kind of an open circuit right there with 2 wires, and they were stripped to kind of make pads that will be on right next to each other. Then we use tongue depressors I got them from the health center. You just use aluminum foil right on the bottom of that, and as soon as you push it down, it creates a short, and they become an active high butt. Oh, my bad.
Alright, so our testing strategy was pretty straightforward. We wanted to make it really modular, and so our design was originally to have both Arduinos run exactly the same code. We had to modify it slightly based on our pinouts, but the Arduinos are running very similar code, so it was very easy to port between the 2 systems. At the same time, it was also a little confusing when we were trying to work on one system or the other to make sure that we had the correct code because it was so similar. But basically, we wanted to start from the bottom. So we tested all of our hardware first. We made sure that we had all our connections, and we started implementing software. And we started with just one button, and we built up to having all of the buttons we needed, and then reading specific buttons, and finally interfacing with our square wave. We had a lot of issues with our original design, and some of those we conquered, and others we just hit the limits of the Arduino and had to accept that we couldn't do it. So the first issue that we came up with was we wanted to populate a sine array of 1,024 characters and save that into our memory so that we could just output a sine wave. The issue with that is that the Arduino only has 2 kilobytes of SRAM, which is the memory that you use to store all of your local variables. So we had to find out a way to put that into the flash memory, which is where the Arduino image is stored. Once we did that, we had issues with accessing the flash memory because you can't access an array the same way. You actually have to use a specific Arduino function to get the values out of the array. So we got that working, and then we started trying to mess with the frequencies. And it turns out that because we were running so many characters in our sine array, we were unable to hit high enough frequencies. We were actually limited by the Arduino's ability to process our interrupts as fast as we wanted to. So we didn't want to have a low quality sine wave for our output, so we switched over to a square wave. From there, we also had some issues with our hardware. We originally wanted to use a shift register, but we were unable to get the clock to go low and high fast enough for our shift registers to read in pseudo real time. So we had to scrap that idea. Instead, we interfaced with 2 Arduinos, and we actually have them sending data across from each other and combining the data from the output. This is a problem when you're using square waves, though, because you can't get clean chords with it. All of our code would work for combining 2 notes, one from each Arduino at this point, but without a sine wave, it sounds really choppy and it just kind of cuts in and out. We can demonstrate that when we get up there, but we do have all of the necessary software to implement multi-button functions. We just don't have enough memory space, or our Arduino clock doesn't run fast enough, so we actually capped out our microcontroller there. So I guess now you want to move to a demo?
Yeah, let's see it.
All right.
So we're in A right now?
Yeah, we're in A right now.
Sweet. So this is our synth. It's got a sick paint job. It's pretty much the main part about it. So right now we're in the key of A. As you can see, it just goes. So there's it all right there.
Yeah. And then if you wanted to, like, as I said before when I was talking about combining the buttons, we have the code there. It just sounds really weird. So that's because of the way square waves add together. So when you add 2 waves, a lot of the time you'll have a wave that all right, I'll draw it up on the board when we're done with this. But basically, when the waves add together as a square wave, you end up chopping between the 2, as opposed to when you add as a sine wave, because it's a more continuous wave as opposed to just on or off. They come out really nice when you add them as sine
Some
wave.
sound kind of cooler than others, though. Yeah. So sweet.
All right, and then we can change key, as I said before, from the key of A to all the other keys, and it just goes through them sequentially. So you'll do B, and then change. And we have a 1-second delay, so it won't output sound for a second.
And it's pretty fast reaction time, too. I mean, you can go.
All right.
Yeah,
so,
it keeps going.
Yeah, it goes all the way through A, and then when it gets up to G, it'll loop back around to A again. So are there any questions in regards to the implementation or any of that?
There's a lot that you did.
There's a lot that we did, and there was a lot that did not work. But I'm glad that in the end we were able to overcome enough of the hurdles to be able to make it work.
Well, the 2 Arduino solution.
The 2 Arduino solution was really cool, and yeah.
Could you use Taylor series approximations instead of?
We tried that, but again, if we were running the Taylor series approximation at every time we wanted to access a value in the sine array, it would just be too slow. But yes, that was our original. We talked with Harris about that, and we actually set it up and populated an array, and then we discovered, oh, this is too big, so I just populated it by hand. I wrote another function. I didn't type it all out every time. But I wrote a function with a different language that would just output all the characters, and then I copied and pasted. So that worked very well. Any other questions?
So the interface between the 2 Arduinos, what actually?
Oh, so we can show you the
Oh,
hardware.
no, just tell me.
Oh, we just ported over from an output to an input, and then we add them together. And it looks like we have a request to see.
It's going to be pretty hard to take it out with this button.
Yeah, we should be able to do it quickly because we had it all off.
It does look pretty cool.
Yeah, it is pretty impressive. There we go.
So we got
that's our
two
hardware. We have
Arduinos
the two
there.
Arduinos. They talk. One issue that we had to overcome was different clocks because the Arduinos weren't perfectly synced up. But we were able to do that by running it from the higher frequency or from the lower frequency to the higher frequency. So it was checking often enough so that it would get the correct notes. But yeah, only one of these is hooked up to the speaker. So all of the sound has to go through the output Arduino, even if it's on the array that is not necessarily.
Again, what was the interface between the
Oh, we
keys
just
on the?
we just ran a wire across and
It's
handled
just
the
out to
interface
in, yeah.
in software.
To a signal line?
Yeah.
Yeah, we handled it with
So
software.
you're
Yeah,
using square wave, so that
Yeah.
would be.
yeah, high and low.
It's just toggling.
Yeah, okay.
Yeah,
And on the keys themselves, what was the interface that you?
they're basically buttons.
Yeah.
We talked about that a little
They
bit
just
in the
create shorts.
presentation. Yeah, so
Pin change interrupter or?
No, it was
no,
just
we check every wait.
just check, yeah.
Yeah, that's
So
what
you're
our wallet
polling?
does. Yeah, we're polling for that.
And
and
that
for the
worked out
button.
okay?
Yeah, that worked out really
obviously,
well.
Yeah.
We were actually really pleased with our response time. We were worried that it was going to be too slow.
Yeah.
Initially, we had an additional key, as you can see here, but we took up too many of the pins on the Arduino over here. We tried to implement the A to D C functionality, but it messed up our clock, and we got some really weird, like, electronic noises.
Kinda
It was
cool,
almost
yeah.
like an electro rave kind of vibe, but that's not really what we wanted for this. So we had to scrap that idea, and instead we had to lose one note of precision, but we're still able to get the full 2 octaves, so I'm not too unhappy about that.
Well, great job.
Thank you.